Hi students, so in this video we'll be starting with a major topic which is called as electrochemical cell. Electrochemical cell. So first you need to know what is actually electrochemical cell and how does it actually works. First we'll study the definition, in short how does it actually works. Electrochemical cell is something which converts your electrical charge into your chemical energy. That's what your electrochemical cell is, right? So before studying the electrochemical cell, like just forget about the electrochemical cell for now. There was an experiment done, right? And what was that experiment? Like the chemist just took a zinc rod or a zinc electrode and dipped it in a CuSO4 solution. This is my zinc rod, okay? And the zinc rod was dipped in a copper sulfate solution. Now this copper sulfate solution, you guys must be knowing that it's blue in color, right? It's blue in color. So zinc rod was dipped in a copper sulfate solution. They kept this apparatus set up for some time and they observed a few of the things after some time. What happens after some time? The zinc rod actually decreased in its thickness. If you can compare the first image with the second image, the zinc rod is decreasing in its thickness. The second difference what we can see is the color of copper sulfate is getting faded. The CuSO4 color got faded. And the third thing which was noticed was there was red color PPT like substance added at the end of the test tube, end of the apparatus. And the fourth thing which happened was the apparatus comparatively became very hot. Okay, so sorry. So there are four things which happened. The first thing was the first thing which happened was the thickness of zinc rod decreased. Thickness decreased. Second thing which happened was the blue color of copper sulfate faded. The third thing what happened was there was a deposition of red PPT towards the end of the apparatus. The fourth difference what happened after some time was the apparatus became hot. There was heat released. Sorry. Hot or there was heat released. Okay, and why does this happen? Because of two reasons only. First was oxidation and the second one was reduction. So why does this happen? We'll study. This happened because of two reasons. First one was oxidation and the second one was reduction. Just remember what is oxidation. Like we'll study in detail what is oxidation is in the redox reaction. For now just remember oxidation means loss of electrons. Oxidation means loss of electrons and your reduction will mean gain of electrons. Just the opposite. Oxidation means loss. Reduction means gain of electron. Just remember one of the thing. Otherwise it will get confused. Gain of electrons. So in the apparatus which we saw before this picture, what was happening? The zinc rod was getting thin, right? Basically what happened was there was oxidation of zinc happening. So zinc is undergoing oxidation to give you Zn2 plus 2 electrons. So electrons are getting lost, right? So that's why it's called oxidation. And what happens in reduction? You have gain of electrons. So in solution, you remember it was CuSO4 solution. So Cu2 plus ion in the solution is accepting electrons, gain of electrons to give you copper. That is the reason the blue color was getting faded and there was red PPT of copper getting deposited. Okay, so that's why that reaction was happening. So there were 3 points which you need to basically remember. First thing is, it was a spontaneous reaction. I don't need to heat that reaction, I don't need to do anything, it was happening on its own, I don't need to put any efforts from my own. So first thing was that it was a spontaneous reaction. Second thing, energy is getting released, right? Energy is getting released. And how it is getting released? It is getting released in the form of heat. Okay, so just revising what was an experiment done before the identification of, before the discovery of electrochemical cell was that they took an apparatus. In apparatus, they just dipped a zinc rod in a COSO4 solution. After some time, what was noticed that the zinc rod is decreasing in diameter, the blue color of COSO4 is getting faded, and there was a red deposit at the end of the apparatus. Why this happens? Because of oxidation and reduction. Now they got the point that something is happening on the apparatus on its own, but there was no productivity in this reaction. Why? Because they were not able to produce electricity. That's what their main criteria was, right? They were not able to produce the electricity, right? That's the reason they then identified electrochemical cell. That's the reason they then discovered the electrochemical cell. Now we'll study about the electrochemical cell from now, that why this electrochemical cell was being discovered, what all names this electrochemical cell has, and how does it actually work. So we are studying about electrochemical cell, which is also called as galvanic cell or your voltaic cell. Galvanic cell or voltaic cell. So in this cell, what is basically happening? Your chemical energy, whatever energy is in the form of chemical energy is getting converted into your electrical energy. Our main purpose of having this kind of cell is that we need to produce electricity. That's our main goal. So chemical energy is getting converted into electrical energy. That is what our electrochemical cell is. I think in before part of the video I have said the opposite thing, just correct it. Here the chemical energy is getting converted into your electrical energy, and this is also spontaneous reaction. You don't need to do any kind of extra efforts to bring out the electricity. This is a spontaneous reaction. If you have studied thermodynamics, you must be knowing any spontaneous reaction delta G is less than 0. If you don't know, don't worry about it. We'll cover thermodynamics topic in the next videos. So just remember, electrochemical cell, which is also called as galvanic cell or voltaic cell, chemical energy is getting converted into electrical energy. It is a spontaneous reaction, or there are many different kind of electrochemical cell. Like for example, you have zinc copper cell, you have nickel silver cell, you have chromium PB cell. All these are kind of examples of different kind of electrochemical cell. Just remember, whenever we are studying about zinc copper, this is where basically we call it as galvanic cell. Sorry, Daniel cell. Zinc copper cell is called as your Daniel cell. This is called as your Daniel cell. So the mechanism of all the electrochemical cell works on its own, works spontaneously. I'll just take an example of zinc copper cell, how does it actually works, which is also called as your Daniel cell, right? So we will now study about your Daniel cell. I'll just draw the apparatus. So here in this apparatus, you have two things, okay? You have two beakers. In two beakers, you have two electrodes, or say two rods immersed. One rod is of, since Daniel cell is what? Zinc copper rod, right? So on the left hand side, on my left hand side, wherever you are seeing the video, the left side is the zinc rod. This is your zinc rod. And here you have your copper rod. Zinc rod and copper rod. They both are dipped in their own solution. Like zinc is dipped in your ZnSO4 solution. Zinc is dipped in your zinc rod is dipped in zinc sulfate solution. Zinc sulfate solution. Now zinc sulfate solution has two kind of ions, right? Zn2 plus plus SO4 2 minus. These are the ions present in zinc sulfate solution. And similarly, copper rod is dipped in its own solution, which is called as copper sulfate solution. Copper sulfate solution, and there are two kinds of ions in it. Similarly, Cu2 plus plus SO4 2 minus. Okay. Now these two rods are connected by an ammeter. Okay. So I'll just give you a trick how to remember what is happening here. Just remember this term. LOAN. Loan. What happens in the left side is zinc rod undergoes oxidation. Left side oxidation, anode negative. Just remember this thing. Left side oxidation, anode which is a negative charge. Right? So zinc is undergoing oxidation. Now if you remember in the previous experiment I have told you oxidation means loss of electrons. So zinc undergoes loss of electrons to give you Zn2 plus 2 electrons, right? So this is my zinc rod. What is happening to my zinc rod? Zinc ions are coming in the solution and this zinc ion is coming in the solution. And these 2 electrons are coming into the rod. The electrons are coming in the rod. And these electrons are traveling here from the ammeter to your this side, right hand side. In right hand side, what solution you have? CuSO4 solution, Cu2 plus and SO4 2 minus. So what's actually happening here? In right hand side, reduction is happening. Reduction is happening. It means copper ion is accepting 2 electrons to give you copper. Copper ion is accepting 2 electrons to give you copper. So again, in short, what is a Daniell cell? It is a kind of electrochemical cell which is made up of zinc and copper cell. There are 2 compartments in it, left side and right hand side. Left side you have a zinc rod dipped in zinc sulfate solution, and right side you have copper rod dipped in copper sulfate solution. In the left hand side undergoes oxidation to give you Zn2 plus 2 electrons. Zn2 plus go into the solution. These electrons get sticked into the rod. The electrons then travel through the whole apparatus and get and from here the copper is getting reduced to give you Cu. Okay. And this reaction is also happening on its own. You don't need to give any kind of extra hard work for this reaction to happen. Now flow of electrons, you all know flow of electrons is actually what produces electricity, right? So after this reaction was set up, you can see some kind of electricity on the emitter will show the reading which shows that the electricity is passing. So left side oxidation, left side is your anode, and anode has a negative charge. Why it has a negative charge? Because your electrons are getting stuck here, right? And on the right hand side you will have a positive electrode. Why positive electrode? In reality this is actually a neutral electrode, but since in comparison to zinc this will be positive, that's why it is called as positive electrode. So just remember this particular thing, the exact right hand side is exactly the opposite of it. So left side oxidation, anode is negative, right side reduction, cathode will be positive. You understood the reason, right? Then, and direction of current will be opposite the flow of electrons. So sometimes directly in exams the question is, In what direction in a electrochemical cell does the electrons flow? So electrons are flowing, just remember, electrons are flowing from what side is this side? This side is your anode. Electron is flowing from anode to cathode, but your electricity is going from cathode to anode, because electricity always flows the opposite. So the things which you have to keep in mind, just remember, there are two particular things: oxidation half cell and reduction half cell. Oxidation half cell is on the left hand side and reduction half cell is on the right hand side. Oxidation half cell on the left hand side, it's also called as negative half cell, and it is also called as anode half cell. Whereas the reduction half cell is also always present in the right hand side. It is called the positive half cell, and this is your cathode half cell, also called as cathode half cell, right? So this is it about your this is it about your main Daniel cell, electrochemical cell. Now in the next video we'll be talking about the salt bridge. A quick revision also I'll be giving you in the next video. So thank you so much.